Problem 56 in the Smith's textbook. We have some carbocations here, and we want to classify them as primary, secondary, and tertiary. Now, what you need to do is locate the positive charge. So here's the positive charge right here. And then we're basically counting carbon atoms. There's 3 carbon atoms attached to this. So this is tertiary. Here's the positive charge, and there are 2 carbons directly attached to that carbocation, or carbon in the middle, so there's a secondary carbocation. And here's our positive carbocation, and it's connected to 1 carbon, so it's primary. Remember that the more alkyl groups you have surrounding the carbocation, they stabilize it through both inductive effects and hyperconjugation. So here, tertiary is more stable than a secondary is more stable than a primary. And I'll just kind of indicate that on the left underneath this, okay? More stable, less stable. All right, and we do the same thing in part B. So again, identify where that positive charge is, and there's only 1 carbon attached to that. So we call this a primary. Here's the positive charge. So we have 1, 2, 3 carbons. So we call that tertiary. Here's a positive charge. There's 1 carbon, 2 carbon. So that's secondary. Okay. So again, we have tertiary is more stable than secondary is more stable than primary. And if you're doing homework or something like that, you probably should draw these out and say, you know, this one's more stable than this one, and that's more stable than this one. Okay, don't just write primary, secondary, tertiary, because that's just a very general response. Okay, so on the left we have more stable, and on the right we have less stable. Okay, so that's how you do this problem. I hope I helped you. Thanks for watching.